Hey there and welcome. You've probably heard that old saying, right? You are the company you keep. Well, it turns out there's a machine learning algorithm that basically lives by that rule. It's called K nearest neighbors, or just KNN for short. And honestly, it's one of the most straightforward and intuitive ways to get started with making sense of data. Now, if you were with us for our last explainer on distance-spaced methods, you'll remember this core idea we talked about, that things that are close to each other in data are usually pretty similar. KNN basically takes that one simple idea and just runs with it. It puts it into practice in a really clever way. Okay, so take a look at this. Imagine you've got this chart, right? All your data is already sorted into these nice little colored groups. You got your reds, your oranges, your greens. Then, all of a sudden, boom, a brand new, totally unknown data point shows up. The big question, the one that KNN is built to answer, is where does this new guy belong? Which group is its home? And that is exactly the problem KNN was made for. Instead of just, taking a wild guess, it does something really logical. It just looks around at the new point's closest neighbors and learns from them. The whole strategy is literally spelled out in its name. So that brings us to maybe the most important part of the name, that letter K. Let's really dig in and figure out what that K is all about. So what is this mysterious K? Well, you can think of it like the main control dial for the whole algorithm. It's the one number that we, the person running it, get to decide. And honestly, the answer is super simple. K is just how many neighbors we tell the algorithm to pay attention to. That's it. If we say K is 3, it'll look at the 3 closest neighbors. If we say K is 5, it'll look at 5. We're in charge. Okay, this visual right here shows you exactly how K works. On the left, let's say we pick a small k, like k equals 3. The algorithm kind of draws this tight little circle around our new point, and it only looks at its 3 nearest neighbors. But now, check out the diagram on the right. If we bump up k to 5, that circle gets bigger. Suddenly, it's including neighbors from a whole other class. So you can see, choosing k is how you decide which neighbors get a say in the final decision. A really simple way to think about it is like asking your friends for advice. Are you just going to ask your 3 best friends, or do you want to get opinions from a wider group of, say, 10 people? K is just you deciding how big that circle of friends is. All right, so let's see this thing in action. The first big way we use KNN is for something called classification. It sounds fancy, but really it's just about putting things into different groups. And with KNN, it all comes down to a vote. Let's make this super easy to picture. Imagine all the red dots are apples, and all the green dots are bananas. Now a new mystery yellow dot shows up. How in the world do we figure out if it's an apple or a banana? KNN does this in 3 dead simple steps. 1. The new dot appears. 2. It measures the distance to all the other dots to find its closest neighbors. And 3. Those neighbors get to vote. And this visual lays it all out perfectly. We start with our data, the red stars and the green triangles. Then our new guy, the yellow square, shows up. The algorithm does its thing, measures the distances, and assuming we set k to 3, it finds its 3 closest neighbors. And what are they? Well, it's 2 red stars and just 1 green triangle. So the red stars outnumber the green triangles, they win the vote. And just like that, our new point is classified as Class A.
Okay, but wait, there's more. KNN isn't just for putting things in boxes. It has another really cool trick up its sleeve. It can also predict actual numbers, like a price or a temperature. This is called regression. And the idea is just as simple. But instead of voting, the neighbors just take an average.
Yeah, so regression is all about predicting a specific value, not a group. The classic example everyone uses is house prices. And it makes perfect sense, right? If you look at houses on the same street, they're probably going to have pretty similar prices. So, if a new house goes on the market and we want to guess its price, KNN would just look at, say, the 5 nearest houses that have already sold. It would grab all their sale prices, add them up, and find the average. Simple as that. And that average, that becomes the prediction for the new house. So just remember that key difference. For classification, it's a vote, but for regression, it's an average. The neighbors all chip in their value, and we just find the middle ground. By now, you've probably figured out that KNN is, well, it's pretty darn simple. And that's actually one of its biggest strengths. But, like anything, that simplicity comes with a few trade-offs. So the good stuff, it's super easy to get your head around. There's no crazy math involved. It's really just counting and averaging. And for smaller sets of data, it can work great. Now for the downsides. That simplicity has a price. For every new prediction, it has to measure the distance to every single other point in your data. So if you have a massive data set, it can get really, really slow. Plus, it all hinges on having a good way to measure distance in the first place. But hey, even with those things to watch out for, the fact that it's so simple and intuitive makes it an absolutely perfect first algorithm to learn when you're just dipping your toes into machine learning.
Okay, let's do a super quick recap of the main takeaways for KNN.
So what do you need to remember? Number one, it's all based on that simple idea that things that are close are probably similar. Number two, it looks at the k nearest neighbors, and we get to choose k. 3, for classification, putting things in groups, the neighbors vote. And 4, for regression, predicting a number, the neighbors' values get averaged. That's it. And that, my friends, is k nearest neighbors in a nutshell. It's a simple but surprisingly powerful algorithm that's all about learning from your neighbors. Now, next time, we're going to switch gears completely and look at an algorithm that makes decisions by asking a whole series of yes or no questions, almost like a living flowchart. We'll be diving into the world of decision trees. I'll see you there.